Hello again. So in another video, we looked at the basic idea of translating three components, A, B, and C, that would fall into a triangular diagram, into components X and Y that we could plot into a scatter plot in Excel. And here we're going to illustrate how to enter those equations. So in that video, for A, B, and C, A was at the bottom left of the diagram. So it would be at the origin where x and y are both 0, bottom right was b, and the top was c. We need to keep track of those to make sure we enter these values correctly. The reason why is our vertical axis y is going to track whatever our top of the triangle component is. So in this case, y is equal to c, so y would just be this thing here, and we enter y is equal to c and just fill down, and we're done with that. The x component requires a little bit of trigonometry, so we're going to use this equation here. So x is equal to the b component divided by the cosine of 30 degrees, and we need to enter that in radians. So we'll write it like so in Excel, so Excel correctly interprets the value. And then for the second component here, we have c times the tangent, also of 30 degrees, which we need to convert to radians. And so that's our equation there, where it's essentially this thing here. And then we can fill down. So what do we have here? We have something that is 100% A, 100% B, and 100% C, and we've derived their XY components. The reason for taking these three particular components is because we can then insert them into an XY chart in Excel, and so now we have the endpoints of a triangle. You can import this into a drawing program and then draw in lines to connect those points, and you would have the boundaries of a triangle. If you wanted to, you can play some other games. You can enter something that is, let's say, 0.5 of A and 0.5 of B and 0 C, or 0 A and 0.5 of B and C, any combination you like. Let's say 0.5 of the first and the last, and nothing of B. And so we can fill these down. And then if we were to plot these points here, they should fall on these lines. We should get a point in the middle of these 2 points here between C and A, and then another point that falls between C and B, and another point that falls on the x-axis between A and B. So we'll just copy those, and then edit, paste special, and so there are points. So you could do that as a check just to make sure that you've entered the equation correctly. So let's say we have plagioclase feldspar compositions. The top of the diagram is traditionally taken as orthoclase, the bottom right is usually taken as anorthite, and the bottom left would be albite. So let's say we had something where we had 80% anorthite and let's say 15% albite and 0.05 amount, 5% of orthoclase. So that point here, these would be the XY coordinates of this particular feldspar composition. So we could copy that and edit, paste special, and that would put the plot, that point into the diagram. So there's where our feldspar composition would plot. We can get rid of all these guys here. We don't really need those endpoints anymore. I got rid of the whole diagram. Let's undo that. So, I guess I'd copied them all as a single series. But again, if you want to do the same kind of game with a different kind of triangular diagram, this could be, let's say, a granitic plot. If you want to plot granitic rocks, we usually have quartz at the top and plagioclase feldspar at the bottom right and alkali feldspar at the bottom left. Let's say we had something that was 50% quartz and let's say 20% plagioclase feldspar and 30% alkali feldspar. So we could take that point, copy it, and paste it into the diagram, and you're good to go. So you could plot anything you like, let A, B, and C be anything that happens to interest you, but just be sure the way we've set it up in defining these equations here, the A component is always the bottom left, the B is always the bottom right, and the C component is the top. If you change that order, then the equations here are going to change.